we are going to talk about chemical reactions, just the basics. So I have a chemical reaction up here. First, you'll want to know that everything on the left-hand side, these are called the reactants. Everything on the right-hand side, those are called the products. So in a chemical reaction, the atoms from the reactants rearrange, they combine in different ways, and they form a new substance or substances, and those are the products. Now this arrow right here is called the yield sign. Yield sign. There are some things that every once in a while you'll see above the yield sign. You could see a triangle above the yield sign, something like this, and that means heat. It means that we've added heat to that system. Sometimes you'll see another element like platinum. That means that it's a catalyst. The catalyst doesn't change from the reactants to the products. It stays the same throughout the complete reaction. It just speeds up the reaction is what it does. So sometimes we'll put the catalyst above the yield sign. Now, to read this, this is how we would read it. We would say 1 mole of phosphorus, this P4, reacts with 6 moles of chlorine gas to produce or yields 4 moles of phosphorus trichloride. Now notice the large numbers here, I use the word mole. These right here are called molar coefficients. There's understood to be a 1 in front of this phosphorus, there's a 6 and the 4. So again, those are called molar coefficients. Now, if I was looking down at the atomic level, I could say if I have one, okay, just one molecule of P4, so 4 phosphorus atoms all bonded together, and I have one of that molecule, it will react with 6 molecules of chlorine gas. So you would have a Cl2 like that, and 6 of them. 6 of those. Let's see, 1, 2, 3, 4, 5, 6. Here, let's do our P4, which that's not going to be the shape. I'll just put that there. And it will produce 4 molecules of PCl3. So you're going to have your phosphorus, this phosphorus trichloride, and you'd have 4 of those. 4 of those, and there's phosphorus off of each of those little bonds that I've written. So we could look down at the atomic level. Think about this. What if I had 2 of those phosphorus molecules? Well, that means if I had 2 of these, I need twice as many of the chlorine. I need 12 chlorine, and that would produce 8 of the phosphorus trichloride. What if we stretched it? What if I had a dozen? What if I had 12? If I had 12 phosphorus, how many chlorine gas molecules would I need? You just saw it. I multiplied this 1 by 12. I have 12 phosphorus, so it's just 6 times 12. We'd have 72 of the chlorine gas, and it would produce how many phosphorus trichloride? 4 times 12. It would produce 48. It would be 12, 72, 48. Notice this is a ratio. These are ratios. So we could make it even bigger. What if I have 1 mole? I have 6.022 times 10 to the 23 of phosphorus molecules. 1 mole. How many chlorine gas molecules would I need? Well, it's 6 times a mole. 6 times 6.022 times 10 to the 23, which would just be 6 moles. And it will produce 4 moles of the phosphorus trichloride. It's going to be 4 times a mole. 6.022 times 10 to the 23. That's why when we read a chemical equation, I can say moles. 1 mole of phosphorus molecule reacts with 6 moles of chlorine to produce 4 moles of phosphorus trichloride. So you can look down at the atomic level, but then we can also look at the molar level. And these coefficients are ratios. They're ratios. Let me give you another example of a ratio that you've used in your life. Let's say that we're going to make s'mores. You need 2 graham crackers, 1 marshmallow, and 3 pieces of chocolate. Well, if you have you and a friend, we're going to make 2 s'mores. You need now 4 crackers, 2 marshmallows, 6 chocolates. It's a ratio. Same thing here. Everything in a chemical equation is a ratio. Now, in addition to that, you will also see the conservation of mass. So in the conservation of mass, it tells us that matter can't be created or destroyed. Okay, it's a law. Matter can't be created or destroyed. That means all of the atoms that we begin with on the reactant side, we have to end with the same number of atoms on the product side. And this is when we're balancing chemical equations, but I wanted to show you that for both atoms and masses using a chemical equation. So we are going to have our phosphorus and our chlorine. We've got two elements in this reaction. So let's go ahead and count our elements. Remember, this subscript just on the right-hand side of an atom tells you how many atoms you have. So we have 4 of the phosphorus. And then if we come over here, so I've got 2, but that molar coefficient, it multiplies. That multiplies. So 2 times 6, we've got 12 atoms of chlorine. Now if we come to the product side, because nothing's written by that phosphorus, it's understood to be a 1. So 1 times 4, that 4 is going to distribute, gives me 4 phosphorus. And then that subscript 3, I have 3 chlorines, but 4 is going to multiply. 4 times 3, we've got 12. And remember, when I wrote down all of the chlorines, I had the Cl, Cl, and I had 6 of those. Well, 2 times 6 of that molecule, 12 chlorines. And here, when I wrote down the phosphorus trichloride, like that, and I had 4 of them. So 4 times the phosphorus, the 1 phosphorus in each molecule, gives me 4 phosphorus. I've got 3 chlorines in 1 molecule. 4 molecules times 3 of those chlorines gives me 12. Now, the point on the conservation of mass, the atoms are equal. 4 phosphorus, 12 chlorine, 12 chlorine. Now, this also holds true for the masses. If I had exactly 1 mole of phosphorus, 6 moles of chlorine gas, and 4 moles of the phosphorus trichloride, the masses would be 123.88 for phosphorus, 425.4 for the chlorine, and 549.28 for the 4 moles of phosphorus trichloride. If you wanted to check this, you're going to use molar masses, and you know how to do that. If we add up the phosphorus plus the chlorine, guess what? It equals the products, the phosphorus trichloride. We can't create matter and we can't destroy matter. The amount that you begin with, the mass that you begin with, will be the mass that you end with. The atoms that you begin with will be the atoms that you end with. Now, this could be slightly different for nuclear chemistry, but that's when we begin dealing with protons and neutrons in the nucleus. When we do traditional chemistry, we will always have a conservation of the mass. Okay, there you have it. Basics on reading a chemical reaction. Good work.